In this session, we will continue with the topic of online analytical processing and multidimensional databases. The focus of this session will be more on the multidimensional databases. We understand why they are required and how are they going to help the online analytical processing, which is the target for creating the data warehouse for the knowledge workers or the decision makers. So we want to enable them to do online analytical processing on the information that is available in the data warehouse so that they can take better strategic decisions. So we first look at something that happened in 1960s when they realized the importance of multidimensional databases. So when a research was going on in MIT as to the how to consider the ways to improve the product sales of that kind of work that was being done by a research scholar, they realized that the person who was doing the analysis was spending a lot more time in reformatting the data which he has received in possibly conventional format. But very little time was being spent on the statistical algorithms or the real data analysis that would tell them that yes, this type of changes can have a positive impact with respect to the business. So then they conceived the multidimensional form of representing the data, and then the research scholar was able to produce a lot of reports in different formats. In fact, the person could do things which were way beyond what he wanted to do when he started the research. So then they thought that it's the multidimensional databases can provide a lot of information and a lot of value when you are doing the analytical work and deciding on the various strategies that are available within the multidimensional decision space that is available to the decision makers or to the knowledge workers. The multidimensional database, to put it simply, it stores the information in a dimensional format. So essentially the multidimensional format. So you may conceive it something like, instead of storing it in a table, it is storing it in a multidimensional array. All of you know how to define the array in multi-dimensions. So essentially what the multidimensional database is effectively storing the information in that format. And how can you do that from a data warehouse? As we know, the data warehouses are by and large stored in the relational format. So when you want to get the information into a multidimensional structure, you will have to do a lot of pre-computation, because hardly any operational system operates in a multidimensional format, nor it is convenient for them to operate, because it's not convenient in several situations. Only when you do the multidimensional analysis it's going to be effective. So, and when they convert it into data warehouse, by and large the technologies are well established for storing large amount of data in the relational format. So in that sense we need to do a pre-computation, and the MDB data is getting accessed through typically the proprietary interfaces. So that is there are several vendors who have come up with their own the implementation of the multidimensional databases, and they provide you the interface. And there was some effort which was being made in bringing in some consistency among the interfaces. And one popular approach is a multidimensional expression, and it is being used by several vendors. And the one significant plus point of MDBs, or compared to the traditional RDBMS, is the support for many statistical functions. So as you know, the decision makers want to look at things like what is the average, what is the median, what is the mode, and so the way they would apply the several functions, what was the kind of variance that they had, that will help them better understand any changes to the business that is happening. Now let's take an example to better understand the value that a multidimensional database can provide. Let's consider an automobile manufacturer. And an automobile manufacturer will be constantly looking at the kind of sales that are happening. And they may be looking at the sales. Let's take a simple example. They may be looking at the sales from the point of view of how each model is selling, and how are the automobiles selling by colors, and how are the dealers doing with respect to the sales, and how is it selling over a period of time. How do you compare the July sales with the May sales, kind of thing. And this is a relatively simple model because they will have a lot more parameters based on which they want to look at, and thereby they improve their product portfolio or the other business angles. Now let's say they are representing the sales data in a relational form, and also let's think that they have only 3 models, though you know typically an automobile manufacturer will have a numerous variants within each model and many more models. Let's say they build 3 types of automobile. One is hatchback, other is sedan, and other is SUV. And then also let's assume for simplicity they make the cars or the automobiles in only 3 colors, and this is the data of the sales volume, let's say for a particular dealer, for the sake of simplicity. So now if we want to represent the same information in the form of multidimensional structure, this is what we are going to get. The information is available in a 2-dimensional structure. In this case, we have taken 2 dimensions, and so that makes it very easy to represent, because most of the time what we draw and what we see on a plain screen is essentially 2-dimensional. 3-dimensional, we need to put efforts to make it look like 3-dimensional, and beyond 3 dimensions we even don't have a mechanism to visualize it. So we need to think in terms of complex approaches as to how to visualize. So we are taking a simplest case, so the visualization here is no doubt about it. So there are 3 colors and then 3 models, and they are represented. Anytime you want to know how many red SUVs the manufacturer sold, they are straight away going into the intersection of the red and SUV, and they are seeing that the 5 SUVs were sold. So this way they are getting the information much quicker. I mean, they have lesser things to search. And as you can see, the representation is far more easier to read and for somebody to understand. And so let's look at some of the advantages or the observations that you can make on a multidimensional structure. Earlier we had seen the same information in relational structure, and there we did not get much information. For example, we said the color is a field in a column, but we don't know how many colors are there just by looking at it. We may have to do the queries, and then we have to remove the duplicates, and then we may be able to get the values. But in this case, we have readily available along the axis, we can see the 3 values, and we know that there are 3 colors that the manufacturer sells. So this is going to help the analyst far more quickly, because when you look at, for example, a sales data, let's say for the automobiles, maybe the automobile company sells over a year, they may be selling 1 million cars. So you can't scan through all the 1 million records to find out how many colors are you using. And also we are looking at the other aspects like the manipulation, if at all we need to do, and if at all we need to represent the information in a different way, that is, we want to rotate the data, then it is going to be much simpler. Now let's make it a little more complex. We have added the dealer dimension to the table. So now we see that suddenly this table is multiplied. We are, for simplicity again, we are assuming that there are only 3 dealers, which you know that it is very unreasonable assumption, but let's use it for understanding. So now what we are getting is that we are multiplying the relational table by 3 times. And now we have got many more records, and when you look at this table, you may be getting some level of discomfort, saying that why is this SUV had to be shown 9 times in the table when I can see that all of them are representing SUV. Probably I can save some memory and some access time, etc. if that redundancy is removed. In relational structure, if you are storing this information, you don't have that mechanism. And now let's go one step and see how does the visualization look. It's so for 3-dimensional, and for 3-dimensional, up to 3 dimensions, we can somehow manage to visualize the information. And now the typical the MDB interfaces, say MDX, they provide you the mechanisms to rotate. So if you want to say that you want to see more prominently the dealers versus the models, then all you need to do is to apply a rotation on the cube, and you're going to look at the information in a much more convenient way. And as you can see here, again, we can get the information much sooner and much simpler way, and given the OLAP operations that we're going to see in a short while, it is very easy to make a analytical session using this information. And now we go further and see what happens if we have more positions. So that is, instead of 3 colors, we have 10 colors, and 3 models, 10 models, and 10 dealers. So this is again a simplistic. This is to give you a better appreciation. In reality, there are likely to be far more dealers, and the models and colors and dealers, the numbers will not be equal. They may have 10 models, 8 colors, and 200 dealers. So that may be more realistic. But let's again see what happens when we increase this number. So now what happens when we are looking at how to carry out the analysis. So we want to know what were the number of sedans that were sold which had a color of blue and sold by a particular dealer. And now you may have realized by now that when there are 10 positional values along each dimension, the number of records that you will have in a table is going to be 10 multiplied by 10 multiplied by 10. So that is 1000. And so a typical database RDBMS will have to scan. I mean, you can create other mechanisms, but you know, there are any other mechanism, the indexing mechanism, which reduces the access time, that comes with a price. So but in general, you can take it that you need to search for 1000 records. You may be able to improve it through some other mechanisms. And now look at the multi-dimensional database. It knows where the data lies. There are 3 dimensions, and so it's a 3-dimensional space. And you know that when you need to locate any point, what you do is you go along the X dimension to wherever you want to go, and along Y dimension wherever you want to go, and Z dimension wherever you want to go, and the intersection is going to represent the value that you're looking for. So in this case, what is happening is that in case of a RDBMS, 1000 records to be scanned, so the average case, the 500 records have to be read. But in case of multi-dimensional database, there are 30 positional searches that are required. The average case is going to be 15. So you can see that there is a significant advantage for this database, which is much smaller than a real decision support database. And to generalize the performance advantage, in case of an RDBMS, whenever you are adding a new dimension, as you have seen, suppose they are adding the 4th dimension, they want to look at the monthly sales, and then immediately they have to multiply the table size by 12 because there are 12 months, and so on. So anytime you have a new dimension, you are multiplying the table size. But in case of a multi-dimensional database, the search space is increasing only by the size of the new dimension. Previously, let's say 3 dimensions, each of size 10, and a new dimension is added, 4th dimension, this has a size of 12. So the search space is 10 plus 10 plus 10 plus 12, so 42. So you can see the bigger advantage that you're getting as the search space is becoming more and more dimensional. But at what cost this multi-dimensional database is giving you these advantages? One is that the multi-dimensional databases are proprietary implementation from several vendors. So unlike the SQL, where there is a lot of standardization, and though the operations are much simpler, and you can't do much with respect to the summaries and the kind of statistics, you can't do so much as in MDBs. But then you know that all the business data is there in RDBMS. That is the best place to keep all the operational data. So what that means is that you have to go to RDBMS and pre-compute the MDB from there. And the larger the data and more the dimensions, you need to spend a lot more effort in doing the pre-computation. So it is not that the analyst is starting the analysis session, at that time you do the pre-computation. In that case, the analyst may have to wait for 1 hour. So which is not reasonable. So what that means is that you need to pre-compute at a predetermined point, maybe at the beginning of the day or maybe at the end of the week. So what that means is that there will be an interval of pre-computation. The moment you have an interval of pre-computation, you are introducing the latency into the multidimensional database. So these are some of the costs, and added to that you have a huge license cost that you may have to end up paying, because RDBMS is, in any case you have the license because you run most of your business applications through the RDBMS. Now let's look at the OLAP operations that again help you understand that how the multidimensional structures are going to make these operations easier. So the common or the relevant OLAP operations for the analysis are the roll-up. That is, you summarize the data. So now you say that there is I wanted to look at the data first by SUVs and colors. That is what we had seen initially. Then you wanted to say that I wanted to see the SUV sales for all the colors put together. So what you are doing is you are doing a roll up. You are adding up for SUV all the color data information, and then you're getting the summary. And it drilled down. So now you are seeing that yes, you're looking at the SUV and color matrix, and you're looking at the information. You notice that red SUVs, so far you had sold 100 of them. Then you wanted to know out of these 100, how much each dealer contributed. It is possible that one dealer contributed 99 and another dealer 1 and other 8 dealers contributed nothing. So you're going from higher level of summary to the lower level of summary or to the greater details, and sometimes you may have to go down further to the highest detail. And then they slice and dice. So when you have got the a cubical structure, you know that you can always slice, and you're going to get a square as a information, which is essentially when you had seen the 3 dimensions of the color, the dealer and the model. You say that you pick up for one color how the sales are happening. So what you do is you're slicing, and once you slice, you're getting you're reducing the dimensionality. Now you have the 2-dimensional data that is representing for the dealer and the model. And similarly, dice is that you may want to select in a different things. So you may realize that the people who buy the SUVs may also have considered the sedan for their purchase before doing that. So you want to combine the two and see what is the kind of market access that you have got for your customers of a particular category. So you're combining the two. Similarly, you think that you have a monthly sales, and you know that some of these sales from the February spill over into the March, and then so you want to combine February and March, and you want to analyze. Or the other thing can be that a dealer's located in a particular locality, you want to combine and see that how is this locality. So there are several reasons why you want to combine the information representing the multiple points and then look at them. And then pivot is one of the operations which helps the visualization better. So you want to convert the 3D series into a series of 2D planes, or you are just going to rotate the cube or rotate the square or the rectangle that you are observing to get a different perspective. And that may give you a better idea with respect to the sales or to the performance, etc. And there are other operations which are done, which is little more complex when they are done. So one is the drill across. That is when you have got 2 cubes. Both are based on different subject areas that you remember. Each star schema is built around one subject area. So one star schema, you want to go to another star schema, then that operation is called drill across. And then the another one is a drill through. So you are saying that you have stored the information at a particular level of summary into the database, the multidimensional database, and then you want to go to the probably the backend relational database and get some of the details that will not be available in the cube. To look at these operations in a pictorial way, so here you can see that when you are going for a roll up, you are getting the lesser dimensions, and when you are doing a slice or drill down, you are getting a more information. So the drill down can be that from a quarter you are going to the months. And similarly, when you do a pivot, the operations are shifting, essentially the information is shifting into a different direction. So this can be, this picture can possibly be, you can look at the slides, and if you think that the clarity is not very good, but this is going to explain to you in pictorial way what I had explained to you in many words in the previous slide. Now let us look at two distinct implementations for the OLAP. So as we have seen, the multidimensional databases are offering us some advantages and at some price. So needless to say, not everybody will go for a multidimensional databases, but everybody wants to do the OLAP operations. So there are two broad approaches that are available. One is called multidimensional OLAP, where you use a multidimensional database and do the operations. The other one is that relational OLAP, where you are going to build the OLAP services using another model, which is essentially you are using a powerful intermediary, which is going to access the information from the data warehouse and going to pre-compute some of the information in such a way that it is still possible to do the OLAP operations. So the pre-computation means that they're going to be in, not necessarily in a multidimensional structure, they may be still in relational structure, but you've got so many summaries that are already available, and then there is a powerful engine that is running in the intermediate server that can enable you to do the OLAP operations. So to summarize the differences between ROLAP and MOLAP, the ROLAP is still dependent on the relational tables to store the information, and details and summary data is available. And then ROLAP being a relational, it can store very large data volumes, and then it can access the data from the warehouse storage because they are based on a similar technology or the similar data storage model. And in case of MOLAP, you are going to look at the relational tables from the warehouse if at all you require a drill through, but the summary data is all kept in the proprietary databases, but the MDBs somehow they don't access the operate with as much of data volumes as the relational databases, considering the one is the proprietary nature, and then they have not been there for so long, as long as the relational database, and have not received the same level of attention. And in ROLAP, you are going to use the complex SQL to get the information from the warehouse, and there is going to be an analytical server that is going to provide you the data cubes, and then you're going to work with them to do the OLAP operations. And the presentation layer has to work to provide you the multidimensional views. But in case of MOLAP, all the data cubes have been prefabricated, and they're being stored in arrays, not in tables. So that means you are getting a very high speed matrix retrieval. And then you can also use the sparse matrix technologies because what happens is that when you create the summaries, some of the summaries are not so relevant. For example, if you're looking at the automobile sales, it is possibly well known that let's say in a small town the sedans don't sell as well as in big cities. That may be the reality in case of with the automobile manufacturer. So you know that there are many dealers who are located in small town. For them, the sale of sedan is going to be zero, or sale of some other type of automobile. So what that means is that you're going to get a matrix where there are a lot of insignificant values. So in such case, the MOLAPs are specializing in the ways to handle it. And Rollup is offering a known environment, and then there are many available tools, and then then the complexity of the analysis is being limited because you know that the storage and then the model is essentially relational. But at the same time, the drill through is easy because you're working with the same data structure, similar data structure, either the summary table to the detailed table or not. And drill across is not always easy because you maybe have to go to a different server or to a different star schema may not be located in the same place. But in case of MOLAP, you're getting a faster access. And importantly, the MOLAP is specialized for analytical operations. So what that means is that they have created a large library of functions that help you do the statistical operations that you would like to do to analyze the information that's there in the cube. And you can also do an easy analysis irrespective of the number of dimensions. You may remember that previously when we wanted to store the information in a relational table, anytime you added a new dimension, there is a simple multiplication of the size of the table. But in MOLAP, it scales up in a far more graceful way and in a far more efficient way. And the MOLAP can provide extensive drill down. So as long as you are within the cube, you are looking at the overall sales and you want to go from the dealer to dealer-wise sales, it is relatively easy. And then you get excellent slice and dice capabilities because the information is in the form of a multi-dimensional array. So you know that in array, if you want to look at, for one of the dimensions, you're looking at the index of value 3 and look at all the values. So it's not at all difficult because you have the entire structure is likely to be in the memory, and then you can read it once. And there is another upcoming area which people are bringing in order to get the advantages of both Rollup and MOLAP. So this is sometimes referred to as a hybrid OLAP or HOLAP. So what they do is they use the Rollup to some extent. Thereby you have the ability to manage large amounts of data. But you want to get the query speed and the efficiency of the analysis that a MOLAP provides. So what you do is that you take some of the summaries, and particularly the most commonly used summaries, and you are going to put them into the MOLAP structure or the multidimensional structure. So if the information that you want to access is not available within the MOLAP structure or the multidimensional structure, then what the HOLAP does is it transparently goes to the backend or to the structure, relational structure, which can store the entire information. And from there it is going to access, and you're going to get the information. And many market actors, market players have adopted HOLAP, and there are some of the top vendors who also give you an option of implementing your OLAP solution. You can take a Rollup approach or a MOLAP approach or a HOLAP approach. So to that extent, you have the freedom with respect to the implementation of the solution. So that is the summary of, so we have discussed in this session the multidimensional databases, and we have also seen how the multidimensional databases and the implementation compare with the well-standardized relational implementation. And we have seen that how the relational and the multidimensional implementations can be combined together to give a more efficient solution for the benefit of the clients. Thank you.